Magnetic forces on a moving charge will be just another tool in your pocket after watching this video. Hello everyone and welcome to a new video. In this video we will be explaining the magnetic force or the effect of a magnetic force on a moving charge if it's moving through a magnetic field. So we learned before that if a charge passes through a uniform electric field, we're still talking here about electrical fields, we're not talking about magnetic fields. We know that if a charge passes through a uniform electric field, it will be affected by an electrical force. But what will happen to a charge if it passes through a magnetic field this time? It will also be affected by a magnetic force. Okay, so charges can be affected by magnetic fields and by electrical fields, but the way they are affected is different from each other. Now, let's look at this simple uniform magnetic field. What do we mean by uniform magnetic field? It means that all the lines are parallel. As you can see, the lines here are all parallel to each other and they are equidistant. The distance between them is equal. So we have a uniform magnetic field. As we can see, the magnetic field is going from the North Pole towards the South Pole, as we can see. Now, imagine that we have a charge and it's moving through this magnetic field. It will be affected by a magnetic force. But in order for it to be affected, two things must apply. First of all, it must be moving. This means that a stationary charge won't be affected by a magnetic field. It will not move. So if we simply put a charge in the middle of a magnetic field and it's not moving, it will not be affected by this magnetic field. So it has to be moving. The second of all, the movement must be perpendicular to the magnetic field. It must be crossing the lines, not parallel to them. In other words, if it's moving this way, it's affected. Or if it's moving this way, it's affected. Other than that, it won't be. In other words, if it's going parallel to the magnetic field, it will not be affected by a magnetic force. But if it's going in a diagonal way, it will be affected. But in this case, we would have to find the x component and the y component. And it's a long story, but the idea is that it must be passing perpendicularly through the magnetic lines. Other than that, no magnetic force will apply on the charge. Now, to calculate this force, it's pretty easy. This magnetic force is equal to the charge, which is Q, multiplied by the velocity of the particle. As we said, if it's not moving, there will be no magnetic force. And finally, we will multiply it by the magnetic field. So the magnetic force is in newtons, the charge is in coulombs, and the speed is in meters per second. And finally, the magnetic field strength is in Teslas. Now, the most important thing is not calculating the force, it's knowing the direction of the force. The direction of the force will not be the same as the direction of the movement. What do we mean by that? We will need to use the right-hand rule. So we will be using the right-hand rule to determine the direction of the magnetic force on the charge. Remember, the magnetic force on the charge is not in the same direction as the moving charge. So again, we have a right hand, we have a magnetic field, it must be a uniform magnetic field, and we have a charge that is moving. Say this charge is moving upwards. How will we use the right hand rule? It's pretty simple. I will make my fingers go towards the magnetic field, and I will make my thumb go towards the movement of the particle. So in this case, my thumb is pointing up. Now, my hand or the palm of my hand will show me the direction of the force, but it's important. If it's a positive charge, it will be going towards the palm of your hand, and if it's a negative charge, it will be going in the direction of the back of your hand. So let's state this one more time. My fingers are going towards the magnetic field, my thumb is pointing towards the movement of the charge, and my palm of my hand will show me the direction of the magnetic force if it is a positive charge. But if it was a negative charge, the back of my hand will show me the direction of the movement. So again, one more time. Do not forget to use your right hand, not your left. We mentioned that a lot, and lots of my students, they make mistakes. They start using their left hand. So please use your right hand. My thumb is pointed in the direction of the charge's velocity. My fingers will point in the direction of the magnetic field. Now, I will ask myself, is the charge positive or negative? If it's a positive charge, this means that the force will be in the direction of your palm. But if it's a negative charge, this means that the force will be in the direction of the back of your hand. And we will be solving problems just right now that will make things a lot more clear. So it's a pretty easy lesson, but sometimes using the right hand rule can be a little bit confusing. But after this next videos, I think everything will be a lot more clear. So stay tuned.